Hello and welcome back to Steaming with Steve. Today we're going to jump back into Python and we're going to look into how file handling works. So basically we're going to look at ways of storing long-term data onto your hard drive using Python, which has a lot of really cool features. So let's jump on in. So to start, when we look inside of a file, we need to think about the components that happen. So we're going to be reading and writing files. So some of you may have seen an old floppy disk that looks like this. Most of us, probably the younger generation, probably thinks that this is the save icon. But this was the way that you would actually save files back in the day. So to cover that, some of the things, we're going to understand the basics of file handling. We're going to learn how to perform C.R.U.D operations, which is create, read, update, and delete. We're then going to write a script then to create, read, update, and delete files. And then we're going to apply these skills to manage some data effectively, some scenarios. So first of all, what is file handling? Well, it's basically being able to read and write to a file. So it's basically so that we can do long-term storage. So in some programs, you might want to be able to access information once the program has finished. So for example, if you're making a video game, you might want to have some way of storing the high score that you currently have, or maybe the level progression that you've just gone through. So to do this, we need to be able to read and write information to a disk. So the disk can either be locally, or it can be on a remote server, or even on the cloud on an AWS server. I've got a diagram little picture here which kind of shows what happens. So you've got a program that outputs the data, so it does a stream of data to a disk file, and then the disk file has been read through an input stream into a data input back into the program if you want to do it that way. So why we open and close files, this is really important. And I've got a little image of a old school samurai at the top there. So when the samurai pulls out the sword, does the actions, and then always puts away the sword at the end. It's the same sort of mindset that we need to have when we deal with files. So basically, to edit a file, we first need to make a connection where we open the file, and then that will either be a TXT file or a CSV file. And then once we finish the file, it's very good practice to close the file. So like putting away the samurai sword, we always try and end that connection. There's a couple of reasons for that, mainly because it stops errors from happening. So if it was on a remote server, you might have multiple people trying to access the same file. But if you have left it open, there becomes some errors inside of that. So when we're reading and writing from multiple sources, it does cause some problems. It also saves the memory allocation so that you can free up the bandwidth that has to happen there. So think of Google Chrome. If you have multiple tabs open, it's not always the best practice. So we try and get rid of those. That helps. So C.R.U.D. Basically, this is a little memory trick so that you can remember all the different actions that you can do within a file. So C.R.U.D stands for the various file operations that you can perform. So you can create a new file, you can read a file, you can update the file, and then you can delete the file. So those are the four main ones that you can do. So C.R.U.D operations been around for a while. Hopefully that helps you remember all those different things. So the workflow when dealing with files. Basically, you'll do the work, you'll want to close the file and save it. You might want to create a new file at the start, and then you might want to open the file when you come back into the work. And that sort of cycle might keep going on and on and on. So in NESA curriculum, we have a thing called a sentinel value, or an EOF, which means end of file. So a sentinel value is located at the end of the file to make sure that the program knows that the data stream has ended. Okay. Usually with most of the questions that we deal with, it's 3 hashes. So having hash, hash, hash in a row is a bit weird. So not many people would have that. And that signifies that it is the end of the file. It's also possible for a system to put EOF, which means end of file, so that you can determine that that's when it is. So for example, there's a bit of NESA pseudocode. So if not EOF, then print out the array value out of X and then end if. Now that's all possible. Generally speaking, usually it's hash, hash, hash or EOF that you'll see. So when you're processing a Sentinel sequential file, which means just a file like a text file, here's the general process that happens with NESA. So begin, we create a file, we open the file for output. So we're going to be creating this new thing. And then for that should equal to 1 to 10, we're going to display the next details of the next person, get the first name, surname, email address, mobile, and then write to friends data from F name, S name, email address, and then the mobile, next I. So that should do the first 10 out of the sequential file. Then at the end, notice that it's used fname and sname is equal to hash hash hash. So then that allows you to have a sentinel value when you open this file to know that it's the end of the file. Otherwise, if you don't have that, you don't know when to stop. So then you write friends data from fname, sname, email address, and mobiles. And then here's the important part. You close the friends data and then end the file. Now, this is the next sort of step that you need to know for nested style pseudocode questions. So it's really important that you understand how to open a file, how to write to a file, and then how to close the file as well. So what is priming read? So a priming read is basically where you read, get some input before you go into a loop or before you start checking something off. The reason that you do this is so that you know whether or not that you've got a file that's going to work. So before starting the loop, the first value needs to be stored from the data file. Otherwise, you won't be able to start the loop. So when you're doing this is why usually you would use a post test or a post loop test, basically so that that doesn't happen. So really important that you do prime reading. And the example of that is when you're doing printing of a file. So in this case here, we're going to display the file contents. We're going to open the friends data for input, and then we're going to read the fname, sname, email address, and the mobile from the friends data. So it's going to read that data in. This is the prime reading here. So priming read has occurred. So then just before entering the loop to provide the first record, if there is one, then while fname is not equal to hash 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 and sname is not equal, so this symbol here when you do less than or greater than, that means not equal in nested pseudocode, display fname, sname, email address, mobile, and then we read the fname, sname, email address, and mobile, and then this reads the subsequent records, which can then be tested for a sentinel value before they are processed, and then end the while. Close the friends data, and then end display files content. So this is a neat little way that will go through every single row inside of your text file and output the names. So then you can also append. So this is writing to a file. And the way that works is you open friends data for append, display, please enter the details of the new person to be added, enter hash 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 for the first and last surname to indicate there's no more records to be added. You then get the fname, sname, email address, and the mobile, so it gets the first value. And then while fname is not equal to hash 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 and sname is not equal to hash hash hash, you write fname, sname, email address, and mobile from the list that you have. Display, please enter the details of the first new person to be added, and then you go through that process again. So then you keep going through until you press hash 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 hash, and then it ends the while. So that's a neat sort of way of adding files to a sequential file. So how do you do this in Python? Basically what we do is we use the open reserve word. So we go file object is equal to open, and then we inside the quotation marks we say the file's name, and then we say the mode. So the mode determines which way that we're going to do. So we're reading, writing, or appending. So a file object is the variable that's going to be stored in the location of the file stream. File name is the name of the file to be opened, and then this needs to include the extension of the file. So if it's a text file, you need to put the .txt at the end. The mode is then the option of the file stream. So are you reading the file, are you writing the file, or are you appending to the file? And there are 4 different options that you can choose. So R means read, where you're only reading the file, so you can't do anything. And if you don't put this in, so if you just put the file name in, this is the default value. You can then put into W, which means write mode. So basically for editing and writing new information to the file. Any existing files with the same name will be overwritten. So you'll basically Thanos them and click them out of oblivion. And then A is append mode, where new data is added to the end of the file. You can then also do R+, which is a special read and write mode, where both read and write is used on can work on a file at the same time. So how do you create a file? Pretty easy. You go file object is equal to open file name, and then W, and then you go file object write, and then that will write that bit of text into the file, and then file object dot close, which is pretty easy. So the dot write function adds information to the file object, and then this will just add some string to the text file as you're building it. Notice that you close the file at the end like a good samurai though as well. So how do you create a text file in Python? We're going to go through and do that now. So we're going to go, a new file is equal to open demo.txt, W. So it's going to create the new file. We're then going to write hello world. We're then going to write the quick brown fox jumped over the lazy dog. Then we're going to write, there is another line of text. And then we're going to write this, that was way too easy to write. And then we're going to close the file. So I'm going to open up PyCharm and we're going to build this code. So we're going to go, let's go new file is equal to open. And then we're going to open a new file. So we're going to call this demo.txt. So it's going to create the new text file and we're going to write it. So I've just made this project called Testing Ground. It's pretty easy to do. And then now we're going to put in the file, the stuff that we want to do. So we're going to go hello world. Sorry, that should say new file, shouldn't it? New file, write, quick brown fox jump over the lazy dog. It's a cool little sentence that has every letter in the alphabet. Then we go new file dot write, and then here is another line of text. And new file dot write. That was too easy to write. And then, like a good samurai, at the end, we close the file. Oh, I can't spell. Brown, and then also need to put a capital T on the front of that. So what you should find here, this first line of code is what opens the file, and then everything else after this is writing to the file. And then at the end, we close the file. So let's run this. Hopefully, awesome, it built it. So what you can see now in Testing Ground, there's this demo text file. Let's open it up. And what you can see is it's just dumped all this text. Now that isn't quite what we were hoping for, is it? Because it's not on a new line. So let's have a look at how that might look inside Python. So it's done it as one big, huge data stream. Hasn't actually sequentially sort of put a new line in each time. So this ties into a thing called the escape character, which we've briefly talked about before. And the escape character is just the /. So when you're dealing with a string, if you use the escape character, it stops thinking like a string and gives you some extra characters that you can sort of play around with. So there are things called string literals, which allow you to use these special characters inside of a normal string and then adjust it to do some cool stuff. So for example, if we did this, so we are so-called quotation marks Vikings from the north, this would actually cause an error in Python, because what happens is it does the string for the first part up to so-called, leaves Vikings and it thinks it's a variable or an identifier because it's not inside the quotation marks, and then it has quotations from the north. So then that can actually break the code. So we can legally write that though, so it is still possible by using an escape character. And the way that you can do that is like this. So we are so-called Vikings / quotation mark Vikings / quotation mark from the north. And the idea here is that escape character escapes the process of knowing that this is actually a special character that must be in here. Cool. So there's a couple of different ones so that you know that these exist. Not just the double quotes, but you can also do the single quotes. You need to do 2 backslashes, otherwise it doesn't work. /n as well will help. And then also you've got the carriage return, the tab, and then the backspace as well. So if we want to do a new line, and we should have seen this before, I can't remember the example, but we have done this, is you can use \n and then that will give you a new line. So creating a text file with the new lines, exactly the same process before. But this time we jam a \n in each row. So if we go back in here, go n, and see how this is why I love PyCharm, because it actually changes the code around so that you can see that they're blue. So then you know that this escape character is something special. So now if I play this, it should override that demo file. If we open it up, bam, there we go. So it's one on each line, new line, which is really, really cool. Awesome. So then how do you read a file? Pretty much the same as what we've done before. So you go file object is equal to open demo.txt, except now instead of write for W, now put the read command in. So let's open this up. Let's change this code for the testing ground. And then this is something neat. I don't think I've shown you yet, is if you press Control /, it'll actually comment out all of the lines of code for you. So if I want to then bring that back, I can then press Command /, and then it brings it all back, which is kind of cool. So that's the same as the question mark. So up here, I'm going to put in our code. So I'm going to go object is equal to open. And then we go demo.txt, and we want to read that demo file. Now we want to print that all that contents out. So I'm going to go file object.read, save, and then let's run that. And bam. So in the console now, we can see that it's run, and that was the code. Pretty neat. So the read function is used to output all the characters in the file into the string so that we can then display it, which is pretty cool. So how do you read part of a file? So this is a little bit more complex. So instead of seeing all of it, we can then just get part of it. So what this does, file object open demo.txt r. Have a play with this actually. So pause the video, see if you can do this and see what happens. Cool. So what should happen is it only is used to read the output of the first 5 characters of the file into a string. So if I change this now and go 5 and press play, it only got the hello because it wasn't able to get much more. So then how do you read a whole line of a new file? We can do this with the .readLine function. So file object, exactly the same, except now, instead of this, we now put line and as a method. Let's run that. Oh, and it ran the whole line and was able to find hello world. So readLine is used to output the first line of text in a file, and it's basically looking for that escape character with the N in it. So how do you put the lines into a list from a file? You can actually read all the lines by going .readLines. So instead of readLine, we're going to put readLines. And then, how cool is that? It's actually made an array of all the different words that we wrote. Sorry, a list. That's another way we say in Python. So it has, with the escape character put in, and it's able to break down and know what's happening inside of that. So the readLines function is used to output all of the lines of the file into a list that you can then iterate through. So now I can now do a for loop through this and pull out each of these list items, which is pretty handy. So then how do you read a file with a loop? So we can now do file object is equal to open demo.txt r, and then for line in the file object, we can then print out the line. So let's just comment that out. Back up the top here, so we'll go file object equals open brackets demo.txt, and we're reading the file. And then for line in file object snaky bind, we're then going to print out line and then run that. Cool. So there's the hello world brown fox, and then it was able to print out a new line for each thing, which is pretty cool. So this for the for loop does the same as read function, but allows for more control of the information because it's going through each line individually. So what does with mean? Now with is a really useful word when we're dealing with files. So with is a reserve word in Python that we use for error handling. So if the file doesn't exist, it allows the program to not fatally crash and then it's all game over. So by using with instead of just trying to open a file, it's basically a really safe way of doing it. So instead of just going file open, we're going to go with open demo.txt read as f, So that opens the file and sets it as the f variable. And then the data is now equal to f dot the read the lines. So that's now made an array called data. And then for line in data, words is equal to line dot split, and then print out the words. So let's see what happens when we do this one. So we'll blank that one out. So now instead of assigning the object, we're going to do with open. That opens the file. So with is the reserve word, and then we're going to go demo.txt, and we're going to read it. And this is where it's a little bit different. We're going to set it as f. Now, as is a reserve word as well. So now the data is equal to f.readLines. And then that sets all the lines into that data variable. Now I can go for line in data, and then that will put all the data into those lines. And then I can go words equals line dot split, and then I can print out the words. Let's run that. What you should see, we've now made 4 separate lists. So it's like a list of lists, but then it's actually split up those words based off the spaces between them, which is pretty cool. So now I have every single word individually. I could do some really neat stuff and do like a word count to see how many words occurred. And yeah, some really neat stuff that you can do with this, which is useful for data mining. And basically it splits it all into those different things. So if you're doing any web scraping or trying to find out what's the latest products out there on the internet, this is the sort of stuff that happens behind the scenes. So here's a little question from Nessa. So Kim wants to write a program with her friends, details in birthday order. She stores her friends' details in a sequential file. Each line of the file contains a name, a phone number, and birthday for a friend, which is the most appropriate data structure for handling her friend's data. So each line's got some data, so it's not just the same thing over and over. It's got a name, a phone number, and a birthday. So pause the video and have a think. Cool. So this is a little bit more complex. So it's not just an array because they're all over the show. It's not a multi-dimensional array. So it's actually B. It's an array of records. So you've got each time you're entering a friend, which is fine. So that's one of the lines. But inside of that, you're going to have this data that's going to be separated by name, phone number, and the birthday for that friend. So then we've got another one. So a sequential file called food data stores the names of students and their favorite food. The following shows some of the contents of the files. So Ahmed salmon, Betty tuna, and Charlie likes whiting. Write an algorithm to display the favorite food of each student in the format shown below. So Ahmed likes salmon, Betty likes tuna, Charlie likes whiting. So just pause the video and try and do the Nessa code to do this based off what we covered way back at the beginning. Cool. So you should have remembered how to open a file. So you should begin, open food data for input because you're going to type this out. You're going to read the name because you want to know who's what. And then while not end of file, read the food and then display likes the food. Display name likes the food, sorry, because that's what the person's typed in. And then read the new name. Right, so then you've got a new name to go again. And then while it's not the end of the file, it will then close the file. Now this is a pretty neat thing because this shows you how these are marked. So this was worth 5 marks in a year 12 paper, which shouldn't be outside the scope of what you should be able to do at the moment. So it provides a correct algorithm that incorporates the following features: opens and closes the file, loops through the file reading the data, terminates the loop at the end, and then correctly constructing and displaying the output, which is pretty cool. Here's another Nessa question. So a company keeps its secure customer details in a file. Each record has the following structure: name, ID, and then password. What is the most appropriate fragment of algorithm to access the record from the file? So have a look through those, pause the video, and have a think. Awesome. So you should have answered C. So reading. So the most appropriate fragment of algorithm to access the record from the file with these different pieces of data is reading but we have to go through each of the customer data points. So the customer's name, the ID, and the password. If you just chose read, it doesn't tell you what to read. So we need to be really mindful with that. So this one's a little bit more complicated, but it's a good one. So you consider the following algorithm: begin, find account data. So it's got the account number, account name, and then the account address. You open the account file, read the account file, and then found is equal to false. While not found, so this at the moment this is true, which is because it's the opposite. If the account file account name is equal to the account number that you've entered in, you then go found is equal to true, and then you go account name is equal to account file account name, account address is equal to account file dot account address. Else you read the next file. So while it's not found, you keep going, and then end the while, close the file account. So there's a couple of questions down here. Just pause the video and see if you can do them. Cool. So the first one is explain how the variable account number is used. There is an error in this algorithm. You need to then describe the error, and then alter the algorithm find account data using pseudocode to take the data found in the algorithm and then print it on the screen. The format on the data on the screen is not important. So this is the first bit. So the first part here, the variable account number has been used as a search variable to find this person's name and address who owns the account. So both those things get returned, and then the variable is used to match the person's account in the search process. So if you identified that it was used in the search, you would get 1 mark. But then if you provide an explanation as to how the account number has to be used, we get 2 marks. The error is that if not found, the algorithm loops indefinitely. So if you go back here, there is no way of stopping found, right? Because it's trapped permanently. So if this is found, it then goes found is equal to true, but there is no end. So we probably need to have some sort of end of file or a sentinel value that we're going to check for, which I think is what they do. So if they just want to describe the error. So error is if not found, the algorithm loops indefinitely. So if you identify the error that loops indefinitely, you would get 1 mark. And if you provide a description talking about the found variables, what's controlling that, you would get the 2 marks. The last question was alter the algorithm find data using pseudocode to take the data found in the algorithm and then print it to the screen. So what they've done is they've gone between lines 190 and 200. So they've said where this code needs to go. You add in print account number is account number, comma, account name is, comma, account name, and then account address is account address. That's it. Cool. So now a little bit more complex one. Use the information in the following parts B and C. A courier company plans to provide outline quotations. The quotation module in the system will calculate the cost of delivering packages to a particular area. The quotation module uses the data provided on the destination and the weight of the package to determine whether the package is accepted or not, and the cost of delivery. So quotation, destination, weight, message, and then the cost. An extract from the table shows the cost for the different situations shown below. So New South Wales, if it's less than 2 kilos, it costs this, 2 to 5, this, 5, this. And then Queensland, this, and then it looks like they're a bit weak. They can't, no delivery for anything over 10 kilos. So a test data file called test data is to be created during the development to test the quotation module. The file contains 4 fields: destination, weight of parcel, expected message indicating acceptance or rejection of the delivery, expected cost of the delivery. So now what we want to do is design an algorithm that will read the data from the test data, which you've created here with those 4 different fields, call the quotation module to determine acceptance and calculate cost if accepted. Compare the outputs of the quotation module to the expected outputs from the test file, and then write the data to an error file if the outputs from the quotation module differ from the expected outputs of the file test data. Cool. So pause the video, see if you can have a go with that. And here is the sample answer that came from Nessa. So begin test driver. We want to open the test data file for input. We then want to open the error file for output for any of the things that go wrong. We then want to read the test destination, test weight, test message, and test cost from the test data. And while test data is not at the end of the file with the test data, you then, test, which is this one here, is not the end of the file because that's what the sentinel value will be reading. It then has a quotation module, which they've assumed here. Yep, so they've got here. So quotation module uses the data provided on the destination and the weight to determine whether the package has been accepted or not, and the cost of delivery. So you just literally put in quotation there, and then if message is not equal to the test message, or the cost is not equal to the total cost, then write TD, T weight, T message, T cost to the error file, and the if. We then read the next one and end while. So then that goes through and reads every single file. And then once we finish, like a good samurai, we close the test data, close the error file, and end the test driver. That's a pretty awesome question. So that tests your ability to read files, and then also how to do loops, and then also how to do if statements all in one package. So some conclusion questions to think about. How can file handling in Python be used in real-world applications? Why is it important to close the file after operations? And can you think of a situation where mismanaging file operation could lead to any future problems? So there is a little Kahoot at the end there. Highly recommend having a play with that. And then if you want, there's some extra file handling questions on W3 schools in Eureka that might be useful for you to play around with. So hopefully that's helped you get your head around how file handling works with nested pseudocode, but then also with Python. There's some really good questions in there, and it pretty much combines everything that we've done so far with reading files, if statements, and then also repetition. So thank you very much for watching. Hopefully you've enjoyed. If you've got any questions, please put them in the comments down below. I try and get to them as quick as possible. And if you've enjoyed this video, please give us a like and subscribe, as it does help with that YouTube algorithm. So thanks again, and see you next time on Steam with Steve. Adios.